Hi, it's Carly McAvoy. I wanted to do a brief video to explain the coefficient of determination, which we note with capital R squared. That coefficient of determination is used to analyze how variations in y can be explained by the x variable. One variable can be explained by a second variable, basically, and we usually do talk about x and y because x is we talk about as our independent variable and y as our dependent variable, meaning that independent variable changes and it causes changes in our dependent variable. This correlation is known as the goodness of fit, and it's represented in a value between 0 and 1. If you think about that as a percentage, it's between 0 and 100%. An example of a strong coefficient of determination would be how high you are above sea level has a direct relationship to the amount of oxygen in the air. So the higher you go in altitude, there's a very direct relationship in how much oxygen you have in the air. You can think of R squared as a percent that gives you an idea of how many data points fall within the result of the line formed by the regression equation. So I think it's easier to show a picture than to say that. So the coefficient of determination R squared indicates how well data points fit on a line. We're not talking about curves in this class, so we're just talking about a line. So here's an example of two lines that are the same line, they have the same steepness, but their R squared is very different because these points are all clustered very closely around that line, whereas these points are dispersed more. So that more dispersion means you have a lower R squared, a very high R squared because the things are really clustered close to that line of best fit. To find that, all you do is take R, which is the sample correlation coefficient, raise it to the second power, and then you can write it as a percentage to help make sense of that value. So for example, you're given this regression equation and you're told that R is 0.732. What proportion of the variation in y can be explained by the variation of the x values? What they're asking here is how strong is that R squared value here. And so you're just going to take that R value, 0.732 to the second power, and then once you get that decimal answer, move the decimal point over twice. It's about 53.58 or about 54% depending on where you're asked to round that. All right, that's all there is to it. Have a fantastic day.